Chapter 15, Section 2, Determining pH and Titration. Titration, it's a method used to find the concentration of acidic or basic solutions by using another solution of known concentration. So if you have any solution with unknown concentration, you can calculate the concentration for it using titration method. So to make an experiment of titration, you have to use indicators. So indicators are substances that have different colors in acidic or basic solution. They change their colors in acidic or basic solution. So an example of indicators, phenolphthalein, it has a pink color in basic solution and colorless in acidic solution. Methyl red, it has a yellow color in basic solution and red in acidic solution. And as you know, litmus paper, it has a blue color in basic solution and red in acidic solution. So now, how to make an experiment of titration. You have to use burette, here the stopcock, has scale, and you have to use flask. It's called Erlenmeyer flask. So in the burette you have to add titrant. Titrant means a solution of known concentration, and in the flask you have to add the analyte. Analyte means solution of unknown concentration, and in the flask you have to add indicator. So for example, if you have known concentration of sodium hydroxide, you have to put sodium hydroxide in the burette. For example, sodium hydroxide, the concentration, you know the concentration, it's equal, for example, 0.1 molar, and volume, you can get the volume from the burette. And here, if you add 50 ml of HCl, and HCl, you don't know the concentration and you have to calculate the concentration of HCl. So HCl, concentration unknown, you have to calculate it, and volume, known volume, for example, if you add 50 ml. And indicator, for example, phenolphthalein. Again, it has a colorless color in acidic solution and pink in basic solution. So you have to start the reaction by opening the stopcock. When you open the stopcock, NaOH react with hydrochloric acid. You have to shake the flask during the experiment to be sure that all the sodium hydroxide reacts with hydrochloric acid. At the beginning of the reaction, the amount of acid greater than the amount of base, so color of the solution still colorless. When the color of the solution changed to pink, you have to stop the reaction. So for example, if you start the reaction with volume 100 ml, and when you finish the reaction, the volume is 70 ml. So what is the volume of sodium hydroxide used in the experiment? So 100 ml minus 70 ml, so for example 30 ml. So again, in titration, you have to put the titrant with solution of non-concentration in the burette, and in the flask, the analyte solution of unknown concentration. So for titrant, you know the concentration, and volume, you can get it from the experiment. And here for the analyte, you have to calculate the concentration, and you know the volume, and you have to use an indicator. Why you have to use the indicator? To get the end point. End point means the point at which the solution changed its color. So what are the calculations? How to calculate the concentration of hydrochloric acid? First, you have to write an equation between acid and base to get the mole ratio between acid and base. So the acid is sodium hydroxide, reacts with hydrochloric acid. The products are sodium chloride plus water. It's a balanced equation. So the mole ratio between sodium hydroxide to hydrochloric acid 1 to 1. So at the end point, or at equivalent point, the point when the solution change the color, so amount of acid equal amount of base. So number of mole of acid equal mole of base. We use concentration, we know the volume. So how to convert mole to concentration and volume? If you remember from the first semester, concentration equal mole per volume in liter. So mole equal concentration times volume. So for acid, concentration times volume for the acid equal concentration times volume for base. Concentration of the acid unknown, you have to calculate it. So concentration of acid times volume of the acid 50 ml. You have to convert it to liters, so 0.05 equal concentration of sodium hydroxide, for example 0.1 molar, so 0.1 times volume of sodium hydroxide. You start the reaction with 100 ml and you finish at 70 ml, so 30 ml used in the reaction. You have to convert it to liters, so 0.03. So the concentration of hydrochloric acid times 0.05 equal 0.1 times 0.03, 0.003 over 0.05 over 0.05. So the concentration of hydrochloric acid equal 0.6 molar. So you can calculate the concentration of unknown acidic solution by using titration method, by using known concentration of base. So this method is called acid base titration. So now titration curve. It's a plot between pH and volume of known concentration solution. So in our experiment we use sodium hydroxide. So it's a plot between pH and volume of sodium hydroxide. So here for example 10 ml, 20, 30, 40 and so on. Here 2, 4. So as you know, when you add sodium hydroxide to hydrochloric acid, the concentration of hydroxide ions increases in the solution, and as concentration of hydroxide ions increases, pH increases. So the change of pH occurs slowly at first, then rapidly through the equivalent point, then again slowly. So at pH equals 7, this point, it's called equivalent point. The point at which the amount of acid equal amount of base. Now some questions. Predict the pH for the following solutions. 1. If you have 10 ml of 0.1 molar sodium hydroxide added to 10 ml of 0.1 molar HCl. So you have to convert volume concentration to number of moles. If number of moles of acid equal number of moles of base, so pH equals 7. If number of moles of acid greater than base, so pH lower than 7. And if number of moles of base is more than acid, so greater than 7. Again, concentration equal mole per volume. So to get number of moles, you have to multiply concentration times volume. And volume in liter, so 10 ml, 0.01 liter times concentration 0.1, which is equal 0.001 mole NaOH. Now what about acid? 10 ml, 0.01 times concentration 0.1, which is equal 0.001 mole HCl. So number of moles of hydroxide, sodium hydroxide, equal number of moles of hydrochloric acid. So in this example, pH equal to 7. Now if you have 10 ml of 0.1 molar barium hydroxide added to 10 ml of 0.1 molar hydrochloric acid. So here 10 ml 0.01 liter times concentration 0.1 times, here you have 2 mole of hydroxide ions in the solution, times 2. So number of moles of hydroxide ion 0.002, and here 10 ml 0.01 liter times 0.1, which is equal 0.001. So number of moles of hydroxide ions greater than number of moles of hydrogen ions. So pH greater than 7. It's a basic solution. Question 3. Ten ml of 0.1 molar sodium hydroxide added to 10 ml of 0.1 molar sulfuric acid. So 10 ml equals 0.01 liter times concentration 0.1, which is equal 0.001 mole of hydroxide ions. And here 0.01 times 0.1 times 2, because when sulfuric acid dissociates to ions, it gives 2 mole of hydrogen ions, which is equal 0.002 mole of hydrogen ions. So number of moles of hydroxide less than number of moles of acid. So it's an acidic solution, pH less than 7.